Today's featured speakers are Moses Frost, SANS Certified Instructor, and Molly Stewart, Senior Cloud Engineer for Blackspoke. If during the webcast you have any questions for our presenters, please enter them into the questions window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Moses.
Thanks, Carol. And thanks, everybody, for joining today as we do this particular talk virtual for the first time. So it's kind of a treat for those that have never seen it before. So a little bit about this talk, and I'll explain this in a minute here. So this is a talk track that we call Postmodern Web Attacks. First of all, my name is Moses Frost. You can, find me on social media. So I work at Cisco. Disclaimer to follow. I teach at SANS, and I author the Cloud Pen Testing class and the Advanced Web Attack class. Today, disclaimer. Right, for everybody that's gonna watch. So today we're gonna talk about what this exactly is and why it's Cloud Edition and why it's live. And then I'm gonna do this whole thing on SaltStack as the first topic. I've got Molly Stewart with me. Molly's was with me during the beta run of the Sec 588. She's got a wealth of experience around. She's an interesting character, right? She's got a wealth of experience around site reliability engineering that I'm sure she'll get into, but she also took my pen testing class and 560 and a couple of the other cloud classes. So very interesting to find somebody that's straddling both spaces. And I've already warned her, no cuss words on the recorded broadcast, only in private. And then we have, so she's gonna do this thing on Azure and some Azure bugs that were out there, and I'm gonna talk about COVID-19 and RDP. And so that's how we'll do this particular talk. So what is this? Why is this Cloud Edition, Live Edition, etc.? So I was doing a ongoing talk track every 2 or 3 months on almost like the state of the web, web attacks, kind of web pen testing and AppSec focused stuff. And we would talk about Docker attacks and Kubernetes attacks. We talked about Rails bugs and some pretty esoteric stuff. And with everybody moving stuff online and moving the courses online at the moment, and everybody shifted to working from home, I decided to do a ongoing talk track series like this at a more frequent cadence. Allows you to ask questions. It doesn't have to be restricted to an in-person event, and we could try out some new things. And so that was the idea behind moving this to an online format. So if you're just joining me for the first time in this talk track, expect more of these, and I'll bring on some different people and some different guests, and we could talk about some really, really cool bugs. And so it's no longer going to be SANS at Night Tech, but I didn't want to make it a SANS at Mike talk, which is a whole other thing. I just wanted to have it as a webcast, ongoing thing that you could come and check out. So let's talk about SaltStack. So for those who have never ever played with Salt and SaltStack, I'm going to give you a brief introduction into the Salt and SaltStack stuff. And I'm going to get into some new exploits that were really interesting with Salt, and just give you an idea for why I chose this one. So, all right, so why focus on the SaltStack bug? Number one, it's web focused, right? So even though it's not a web app, even though it's not a web technology, its command channel is very web-like. It uses web-like calls. So it's a very web-like kind of product. So I thought that was check. Number two, it's a Python-based stack. And so everybody's always saying that I pick on really crappy languages like JavaScript and PHP. And how can you blame me? They're really crappy. But Python gets a turn too. It's a loved language, and you can still do some dumb things in Python. Also, really interesting, this whole thing was exposed to the internet by accident, right? And so we'll talk about that. That's kind of interesting. And so because of that, there was a lot of cloud applications that got hit with this bug and how you could use it. And so all these checkboxes work. So it checks out. We should talk about it, right? All right. So what is SaltStack? So you go on the website, you look at the tutorial, and basically what it says is it is a configuration management system. So Puppet, Chef, Ansible, trying to think of what other ones are pretty, PowerShell desired state configuration, right? All these systems are basically out there for you to manage the configuration of multiple, clusters of hosts and whatever, right? Okay, cool. What else? My favorite part, distributed remote execution system. So the number one, arguably the number two, because I think they really harp on the number one. The number one thing that this thing is designed for is run commands, okay? Just run commands. And it tells you that, because of the way it works, it's designed to give you like a heterogeneous environment, run commands, right? So you've got a system that its entire thing, that the number one thing it does is to run commands. So you probably want to make sure that this thing is secured, right? And I'm going to be honest with you. Part of the reason that I moved from Chef and Puppet and some of these other tools was because their command channels were basically web-like, built from the ground up. Whereas if you look at PowerShell DSC or you look at Ansible, right? Ansible is a little bit more hard to do certain things, but its command channel is SSH. And say what you will about exposing services to the internet, SSH is a pretty battle-hardened, decently secured mechanism for running commands in a remote system, right? That's the idea. And so this one was kind of interesting, first of all, because people do use Salt in the SaltStack. However, it's not as popular as some of the other ones, so it's almost like esoterically used, which is kind of interesting. Like, not sure how you make the decision of using Salt versus Puppet or Chef or Ansible, but interesting that people use it. It's been around forever, by the way. Now, this, I took it from the Salt documentation just to kind of like give you a 30-second snapshot as to what the hell is going on here and how does it work, okay? So step one, you have the Salt Master and the minions, right? Which is a good choice on words, right? Not master slave, because people had issues with those words. So master minions. All right, cool. So you got the master, you got the minions, and one master, and everything else that you manage is a minion. And then when they talk, they don't talk over port 22. Now, I want to harp on this for a minute because I think this is really interesting, right? They call it publisher and request servers, server requests, right? So publisher, when I looked at the architecture a little bit closer, right, with the request server publisher thing, what I noticed was that the publisher is actually 0MQ based. So it literally is a publisher subscriber model. If you don't know what I'm kind of getting at, there's a few types of ways of organizing your service bus. We'll call it a service bus, right? And one of the design patterns for a service bus is this publisher subscriber model, where you have a master node, like the Salt Master, that will send out a request and it will publish it out to, think of it like a chat channel, right? Think of it like a Slack channel or Jabber chat channel. And so a message queue, in this case, by the way, I think it's 0MQ. A message queue, all the nodes will join and it'll say, oh, okay, like, do I have a new job for me to do? And it's like, yes, you do. And so it's kind of how it works. So it's a publisher model, it's a request server. Now, if you talk to many folks about how they do their Puppet and all this other stuff, they will tell you that you can expose these things to the internet if you go through the trouble of hardening them. Now that is a questionable practice, but that's what they say, right? And so this system has these 2 ports exposed. Fantastic. Now I looked online, by the way, and I looked for these ports, and I didn't do much deep packet inspection. I didn't go in there and like try to like do a curl or anything. I just said, hey, Shodan, tell me what you see from these 2 ports. And each of these 2 ports show about 6,000 hosts apiece. I think port 4505 showed 6,000. I want to say 4506 maybe showed less. I think it showed like 2,000 or so, but which would make sense. There's more minions than there are masters, right? And so that seemed to be interesting in and of itself. Now, and by the way, as I go through this, I just want to make a mention that there is a Q&A chat channel that me and Molly are going to be looking at. So if you have any questions, because we're going to get into some deep stuff here, if you get any questions from any of the presentation topics today, put them in the question and answer section, and I promise to look at them, and while one of us is talking, we'll either hold off the questions until after, or alternatively, one of us will answer it directly in the channel. Anyway, so we from what we could tell, there was a ton of these hosts exposed on the internet. It's kind of interesting. Now we'll get this out to you. The master and the server do have this concept of public key, private key kind of authentication. Now, many folks will be like, well, it's public private key, it's SSL. There's we do authentication in websites today, right? If you have a public private key setup, this should be secure enough, right? That was the idea. However, there is a bug. There's a bug, right? The Saltmaster bug, with the Saltmaster process, has something called clearfuncs, right? That's the method, clearfuncs. I would assume that the method clearfuncs is actually a way to clear out all the function calls that may be in memory or whatever, right? Anyway, it says that there's a class called clearfuncs that does not properly validate method calls, and it would allow a remote user to access some of these methods without authentication, okay? And so when a Salt minion is talking to the Salt master, if you try to actually send requests out of band, right, if you actually try to communicate with any one of these components, these method calls that were there are probably supposed to restrict random connections that would be unauthenticated, right? And so the authentication is supposed to be public key, private key. You're authenticated, run a command. It appears there was a special class that is a function call clear, a way to basically clear out function calls. It appears that class was not doing authentication. And so if you can access that class by just communicating with that port, it would allow you to not just run commands, but it would allow you to retrieve the tokens from the Saltmaster that would allow you to run commands, right? And so you became your own Saltmaster to all these minions that were out there. That was basically what it was. Here is a view of, and by the way, I do give these links. Here's a screenshot of the commit that went into GitHub, because Salt is open source. You can actually see this. You could see the red, by the way, if you've never seen a GitHub commit. What it is the red is the old lines, and the green are the replacement lines. And so what they did, you could see at the top here in line, and I'll just highlight it here, right? So if you ever want to look for this as a bug hunter, right, or if you ever want to know how to build a vulnerability, an exploit to a vulnerability, you got to read some code to understand what's going on and try to reverse engineer it. But even if you don't build the vulnerability, the exploit code yourself, if you just want to understand a little bit more about what's going on, here's what's happening, right? So you can see that the command starts, if the command starts with 2 underbars, it would return false, right? And so you had a specific method that would go out and clear functions, and this is the method name. And if the method was not around, it would return an empty array now, and this is what would be sent. So basically, in the past, they were not checking the method at all, it looks like. At the same time here, all you would need to do is set a specific line to basically get the attributes of clear functions and the command to load. Now, it's just loading the method and sending the command. So they've changed the mechanism in which these function calls are running. And then my favorite part of the whole thing is that before you had these, this like object that was being passed into this class, and it was a generic object. It actually wasn't like a standard object, and there really wasn't any functions in here that were being used. Well, now it's like, no, we can't do that. We've got to make sure that the methods that are exposed are only these methods and not anything in the world, because these methods are probably going to have authentication, whereas the other methods are not, right? And so the clear function method was an example of a method that didn't have any authentication on it, but because it wasn't checking to make sure that this was something that was supposed to be exposed to the internet, it was accessible, right? And so you have a situation where you've got a method that is not authenticated, accessible to the world, that allows for actual use. And so basically, the way that I like to think about this is that it is a mass attribute kind of attack. Now, if you don't remember or know what a mass attribute attack is, we covered this in 642. But the idea was that in the earlier model view framework, model view controller frameworks like Ruby on Rails, you would have these method calls, and in the early days of these frameworks, the method calls were not actually checking for authentication. So if you knew how to call the API, you could do the thing, right? Even if you weren't allowed to do the thing, it would allow you to basically do the thing, because it wasn't checking for your authorization. It was just checking that you had a valid request. So same thing here, right? It's kind of like that, where you basically weren't authenticating. As long as you could properly form the authentication, you're good, right? And so what you could see is the crux of this thing. Somebody actually wrote a decent exploit. You could read it. This exploit that was written basically takes the libraries from Salt, and the Salt libraries are, for the most part, being called in directly into the system. And the Salt calls are just libraries that come in. And so with the Salt call, you get a call to actually get the root key from the Salt master. And then the crux of it is down here. And you can see that it's a JSON array. That's what it looks like, where you're sending to the publisher a command. And by the way, you're specifying the commands here. And if you look, this actual method was being called back here, right? Where this was the actual command to clear out the function. Now they're now making sure that you're clearing out the function, whereas before they just weren't checking that at all. So if you look at here, they're basically running a command using that same function call, and then they're passing an argument, whatever you want the argument to be. And so this, and they're passing job IDs, and they're saying that you're doing it as a user root. So as long as you know how to talk to the API and can formulate the right call, you could take control of a Salt master, or a set of Salt minions. So it's basically command injection that was available right through the internet. There were people that got hit with this, okay? So who got hit with this? And no, it wasn't these ads. There was at least 3 major providers that did come out with a posting that said they got hit with this. DigiCert the people who mint certificates, they got hit with this by having one of their nodes, not all their nodes, but one of their nodes was affected. And so just because the node was affected, it would appear that they had to go to, say, I think it was a Google Transparency Report people and say, this node in your certificate transparency report must be deemed or must be rejected or revoked because we can't guarantee it. So that was that fallout. One of their nodes, one of their many nodes, got impacted by exposing it to the internet. So don't expose Salt to the internet, right? The Ghost blogging platform, which is a newer style Node.js blogging platform, they got hit and they had to do password reset and everything else across their system. And then the other one that I thought was interesting was an operating system kind of distribution called Lineage OS, which is a Linux operating system distribution. I believe their build servers got affected by this and they had to fix it. Now, there doesn't seem to be a lot of adoption of Salt. I mean, it's used by a lot of people, but it doesn't seem to be as prevalent as some of the other configuration management tools, and it doesn't all seem to be exposed to the internet. So you might find that there are still Salt stacks that are not patched, but that are not also exposed to the internet. So you may want to look internal networks and in internal systems to see if Salt's running on those two ports, and if you can actually get them to run commands, even if the commands are like ID, which is not impactful. If you get an answer back, you know you've got an issue with a vulnerability there. So that's Salt, and that's the first of our buckets of fun here. And so I want to pass control over to Molly. Let's see. Molly, are you there?
I'm here. I'm unmuted.
You're there and muted. That's amazing. Hold on. Did I pass you my controls? Let's see. Yeah. Let's see.
Looks like you can click in now and take control.
Yeah. Yeah. There you go. There you go.
Oh.
Fantastic.
Okay. Awesome. So I can't take control.
You can't? Oh wait, you know what? I think it's stuck on pen mode. There, let's get rid of that. There we go. Can you go forward and back? There you go. Yeah, there you go. You went too far.
Okay. I'm still going too far. Correct.
Go the other way. There you go.
Okay. Awesome. Perfect. Hooray. So yeah, I'm going to talk a little bit about the latest Azure exposure, I should call it. My name is Molly. I'm a cloud engineer on an SRE team. I work for Blackspoke. I've got some certs. I've got degrees ITA for SANS for 545, Cloud Security Architecture and Operations, and 588, the cloud pen testing course that Moses has written. And then I've written some blogs for CompTIA about the cloud and about pen testing. I have over 10 years of experience across the realm of civilian and military. And two fun things is my life is pretty much cats and roller skating and roller derby. So yeah, pressing on. So Microsoft, as you can see these headlines from Forbes, from GeekWire, had exposed potentially 250 million customer service records due to a misconfiguration of an internal database. And if you kind of look a little closer to that, Microsoft Response Security Center, they released a statement about it, saying that what happened was they changed the network security group within Azure. In the beginning of December, they recognized it towards the end of December and fixed it, but it was kind of open there. And then about a month after that is when all these headlines started popping around. Basically, what the database was customer analytics. It had been pretty much automated kind of purging of any potential identifying information of the customers, but it was an automated process, so there's always room for error there, depending on how they have it coded. There's some links here if you're more curious. But the other piece I wanted to mention is network security groups. Like what are they, what do they do, and how does that amount to a database? Okay, so what I wanted to do is take a picture to visualize this. I used Network Watcher to get a network topology. I deployed some databases in Azure. I did an Azure SQL DB, and then I did an Azure SQL virtual machine for SQL. As you can see towards the bottom of the screen and highlighted, I highlighted the security groups and kind of where they sit. They're a stateful host-based type firewall. They're attached directly to the interface. So you can be applied to each server separately. So once I had deployed those databases, I had to figure out, well, how do I know that they're secure? How do I know what I did was correct? Trying to kind of repeat what could have happened potentially with Microsoft to get a better understanding of it. So I went into the Security Center, and I noticed that for my SQL VM, it did alert me on a couple different pieces with those network security groups. It told me that my network ports were not restricted on my security groups, and they should have been, which that just alerted me to saying, hey, I had something open to the world right out the gate, which is kind of similar to what happened to Microsoft. The other piece of it, for management ports of the VMs, need to be protected with just-in-time network access control. So what that is, that's actually really interesting, and it's something I haven't seen a whole lot where I work, because I work mostly in AWS space. But you can adjust those security groups for temporary amounts of times to allow someone in to access just for while they're trying to manage it, and then it'll close it up after a certain amount of time. So I thought that was really cool. Security Center has some neat features. You click Quick Fix, and it'll help you just remediate those findings for you. So from there, what I did was I wanted to figure out how I would exploit this. So if I had a SQL database open to the wild, I wanted to use Metasploit, and I wanted to try to brute force my way into it. That's kind of what I would do if I found something open on the web. So what I did was I used the auxiliary scanner MS SQL login module. So I decided I would create a little word list, a short word list, short password list, and feed it into this module and point it directly at my SQL VM. I actually pointed it at both my Azure DB and my SQL VM. And I realized that for some reason, I don't know, maybe someone else has seen this before, but I actually couldn't get this module to work on that managed Azure SQL database. I think it may have to do with the way it was deployed or how Microsoft works, but I definitely want to dig into it a little further. But I was able to get into my SQL VM, as you can see here, success, log in. So I said, okay, so now I proved that concept that I could get through, and I could kind of see what could happen potentially if I had that security group open. So that's kind of what happens when it opens. I want to kind of go lead into Microsoft's response to this whole outcome of this. Microsoft wanted to establish some better auditing for their network rules. They wanted to expand some detections for misconfigurations. They wanted to add some alerting, and then they wanted to implement some more redaction automation as far as their customer analytics database goes, so they're not potentially exposing more information. So auditing, I thought that was neat. I wanted to kind of follow through the auditing section here. But aside from auditing, there are other things that you could do to build this up. Basically, I kind of say, get your head out of the clouds. A lot of people want to bring stuff into the cloud and kind of use it as like blob infrastructure and just deploy anything they want in the cloud and not really think twice about it. So for being kind of an interesting standpoint, kind of think about from the ground up to get to the cloud. Aside from setting up auditing and alerting and your network security groups, there are a couple of other features and things you can do, ways you can design and architect your cloud environment to help do that defense in depth strategy that will mitigate a potential open network security group. So within your cloud, you have your virtual networks, and you can separate different subnets within those. A lot of places will separate their database subnets from their application subnets, from their web subnets, and they'll lock them down with access control rules, ACLs. Aside from that, they'll separate those database subnets with specific route tables, so it can't even get out publicly, even if it was allowed elsewhere. The other piece that I really like, as far as if you're going to redeploy things in your network, is to use that infrastructure as code piece. I know Salt, like Moses was talking about, is a big one that some people can use in their cloud environments. You could use Terraform, you could use different types of information templates to redeploy things. You could have those redeploying and reinforcing on a regular basis. So if something does change and it wasn't supposed to, it'll get written back over. You could also deploy, make your templates so you can deploy to the same compliance requirements every time. And I think that's really helpful, because then there's some little details that may get overlooked if you're manually deploying that won't be. The thing I need to be careful with the infrastructure as code, because I've seen it where I've worked before, is that it can also overwrite good changes if you're not following through on how you're actually updating that infrastructure. If you're reinforcing it every 15 minutes and someone goes and makes a manual change for some reason, it'll get overwritten. So that's problematic. Okay, and then the other pieces for this, like Microsoft is doing, alerting on those security group updates, alerting on non-compliance for open to the world security groups. Microsoft calls this any. Some other clouds will just have it as like a default 0000/0. So alerting on that. And then you can also have some reactive actions. You can take those alerts and you can feed them into something like an Azure function, or for other clouds, a Lambda function. And you can remediate that non-compliance based on that change from that alert. So those are some things that you can implement from the ground up beyond just auditing and monitoring. But I wanted to check in on some of the auditing piece and see how it worked in Azure. So what I did was I needed to set up my network security groups for auditing. They have to have diagnostics on first. And I went to the GUI and I couldn't get it to alert on the updates I wanted. There were a couple conditions that were kind of there, so I clicked and I was like, okay, network security groups, alert on mod or update, create or update network security groups. So I tried it out and it didn't work. And I'm sitting there, and so I have a friend, he works for Microsoft. We started off together and we went different paths. I went to like a Linux fangirl and he went more Microsoft. And so every time something mildly inconveniences me about Microsoft, I call him and I ask him, why does your stuff not work? Why is this horrible for me? And we just give each other a hard time over it nonstop. So I messaged him and I was like, why is your cloud like this? Like, is this just slow? Is this me? And he's like, it's probably you, but let me look. And so he went in and looked at it for me, and why this alert from the GUI wasn't actually alerting on that security group change. And what we found out was that we needed to set this condition up within PowerShell. Okay, if I can click. So what we did was we had to set our conditions that weren't options in the GUI. We actually alerted on security rules, which are the individual allow, deny, source destination piece of that security group. Security group being more of like a post-based stateful firewall. So you see here's kind of the code we used that I used actually in my cloud, just so I could see, okay, this is how it's done. So I can't really blame Microsoft too much for not being notified on some of those changes, because that GUI was kind of it was a trick for me. But like I said, got through it. And then what I needed was to have network security group security rule be the call for create or update modifications. And from there, we saw success. And I was able to get my message. I had set up the alerting for my cell phone, but you could set it up for different endpoints, emails, web, however you want. But yeah, I had this one set for my phone, and I was able to get my alert successfully. So overall, I walked through creating some databases in Microsoft, making sure the security groups were open, seeing kind of what security settings I should search for to make sure everything was secure. I then tried to use my Metasploit MS SQL login module to try to get through there and log in, and it worked for me in at least one of my cases. And then I set up my alerts to see when my security groups changed. So I kind of tried to walk through that whole life cycle to get a better understanding of what had happened and how I could prevent that from happening to me. The other piece of this, like I said, Azure, they have a whole lot of documentation on Microsoft's website about Azure if you're curious and wanted to learn more. More Metasploit stuff, sure, offensive security, take some SANS classes. They're pretty good about that type of stuff. But from there, I guess I'll hand this over to Moses.
That's pretty cool, Molly. That's really, really cool. I was curious, I guess if you don't have a phone to friend at Microsoft, is that like a support ticket, I guess you'd have to open?
Yeah, I would definitely. Your subscription, you can pick varying levels of support. There's a support included model that I think it's like $15 a month or something from what it was yesterday. But yeah, you could put in a support ticket and they would come back and tell you probably why it wasn't working.
Yeah, that's crazy. I guess you could also, okay, OffSec folks, I guess you could also have, this gives me an idea. New module for class, right? I guess you could also have it trigger an alert the other way around, right? So like if a bad guy sets up an alert that somebody has logged in or some other action, you can have it call a backdoor or do something else as a Lambda function. I guess you could use it against the offenders as well, I would imagine. Or if they log in, you can delete yourself or something. I don't know.
Yeah, hide yourself in time to not be found.
Yeah. That's kind of interesting. All right, cool. Very cool. Yeah, I kind of like that kind of research. It's a interesting world, that cloud world, huh? But here's a fun one. So I guess we'll leave this as, oh, you know what? There are some questions, and I realized something. I realized that you're controlling my computer, so I wouldn't be able to answer any of my questions. But let me see if there's any questions that needed our attention right now, or that the audience could use. And I had a few. There's one here that we'll answer at the end. All right. Well, there's one that we'll answer at the end. Okay. So let's talk about remote work. So I'm not sure what where everybody is, because we do have global relationship out there. But I would imagine there's quite a few people that are working from home. Not everybody, especially depending on the kind of work you do. You may not have the ability to work from home. But there are many more workers working from home today than there was, say, in January or even December, right? All right, so I want to put this up because this is kind of scary for many reasons. The fact that there's an RDP session on your screen should be interesting. The fact that it's a Windows Small Business Server 2011 standard edition that's kind of like 9 years old today, and probably is based off of a 2008 R2 operating system, should be scary, right? And so the question's always asked, how many people view RDP as a secure channel to work from home? This might sound kind of crazy, because RDP would not be my first choice when it came to, especially RDP on port 3389 standard, right? Would not be my first choice as a login mechanism. But you can see where this has maybe become the login mechanism of choice, right? Yeah. This is, by the way, for those that don't know, I do a whole series of talks on this guy, which is the Are You Serious guy. So yeah, am I serious? Yeah. So March 16th, I remember Leslie Carhart, who was Hacks for Pancakes, put a question on Twitter. It said, has anybody done metrics on how many new RDPs are out there and how many vulnerable, have gone up, right? Now, this is a week after California, or maybe 2 weeks after California decided to close, and the US, countryside was starting to close state by state. And so there had already been folks at this time that were probably setting up remote desktop sessions as it is, right? At least enough to prompt the question to be asked. And I didn't get the screenshot, right? I wish I would have gotten the screenshot. But as of March 17th, my answer was, according to Shodan, there was almost 4 million RDP sessions out there. And I saw some questionable ones, right? Almost 4 million. So I don't know if it was 3.9 or 3.8 million, but let's just say 3.8, 3.9 million RDP sessions that were known by Shodan in March. So in preparation for this, I decided, hey, I wonder, now that we are, I don't know, we're 60 days or so, at least in my scenario, we've got to be 60 to 70 days into a lockdown. How are we trending globally into the number of RDP connections? Surely there can't be that many more, considering the fact that we have all this free VPN stuff that's being offered by various vendors. Boy, was I wrong. So it looks like we have an increase of almost 700K. Yeah, the presentation on Monday should be like 4.9 million. We have almost 700,000 new RDP servers, or at least port 3389 out there in the last 70 days, right? So that is exponentially more, right, than I would have thought that are out there. And by the way, when I look at this data set, when I actually look at the Shodan data, I'm not seeing 4.9 Windows 2016 or 2020 beta or Windows 10 I'm not. I'm seeing 2008 servers. I'm seeing 2012 R2s, 2012s that are showing up on the console. So it could be that these old servers were there and now they're showing up in a much closer to the front of the line and just showdown queries. I hope it's not that people took existing 2008 and 2012 servers and stuck those on the internet that weren't there before. It's kind of hard to do an A/B comparison because I don't have the catalog of all the pictures from before and after. But it would appear that RDP is actually being used as a login authentication mechanism for some fact, right? Some facility, somewhere along the line, this has come down as okay. So let's talk about this not being okay for a minute, right? Now here's the other thing that I thought was interesting. I went ahead and I grabbed the Internet Storm Center data for port 3389 that basically shows scans by targets, scans by sources, that kind of stuff on a day-to-day basis. And I haven't gone back to Johannes and asked him why this is showing up differently. I don't know if it's because large sections of the network people have turned off. I don't know if it's, I'm not really sure what the discrepancy is here, but for some reason, right around April 1st, the number of targets per day and the number of sources seem to decline a lot, right? And so it was very, very spiky. And then at the point when it should have actually increased and peaked much, much higher as an attack surface or as a scan source, it seemed to go away. So I'm not sure what's happening here, but this seems to be a much broader set of issues that have caused this target data to get much higher. So it's interesting. I'm going to set up a couple of honeypots myself to try to figure this out myself to see if the scans are increasing or decreasing. But no bueno. So just as a PSA for those that are evaluating cloud infrastructure environments and connectivity mechanisms, I'm going to give you a couple of items here that I wanted to talk through for you all. So first of all, I saw on a mailer, I'm not going to say which mailer, but I saw on a mailer a conversation around risk and COVID and things like that. And my viewpoint of this is that the riskiest time for a red team organization or a red team group to work was right around the time that everything shifted to remote work, right? So this time right now where there is very minimal activity inside of an office building might be the worst time for that red team organization to work if you have a bevy of implants that are basically not ideal, right? Just a bevy of implants that are that might be seen because you're not hiding in legitimate traffic because there is no legitimate traffic inside of the office anymore. So blue teams might actually find implants that have gone undisclosed. But I will tell you that the riskiest time for the organization is also now where a few things are happening, right? One, everybody went remote work from home immediately, and the border of your perimeter of your network went all the way to somebody's at-home desk. And so that's a problem because you may not have the safeguards and securities at that office environment, and you may have done the thing of like, hey, let's open up 3389 because it's encrypted, right? So we're going to talk about that here in a second with the encryption part. The other thing is that when people come back to the office, right, whenever people start coming back to the office, whenever that is for your organization, all of that anomaly detection stuff that had been broken from everybody leaving and not being able to do anomaly detection because now there is nobody working from the office, it's not going to work immediately when people come back into the office because all of the baselines for the anomaly detection tools have already reconfigured themselves to nobody working from the office. So it looks like everybody's attacking each other because the baselines have to get reestablished. So the risk for the organization is gonna be when all these telemetry and all these machine learning algorithms are just in flux from the shifted moving of operations and stuff, right? So RDP, what's wrong with it, right? RDP as a protocol was initially designed for internal remote access, all right? So when you look at things like NetScaler and the Citrix ICA protocol, which RDP was arguably augmented by, and you look at the different technologies, can you use RDP from the outside? You can. I don't think it was designed to be a fully secured protocol. You really don't have a good way of doing PKI in it very well. If you've ever tried to get a actual valid certificate into the RDP stream, you know that getting PKI to work so that remote desktop protocol doesn't prompt you with, hey, do you trust this connection, is kind of difficult. So that's an issue. You can man in the middle of it. That could be an issue. And then most people don't actually secure their RDP with MFA. So if you can brute force a username and password into an RDP session, which you can use THC Hydra, you can use all sorts of tools to do this, then you've got an issue where you've got potentially either a man-in-the-middle situation that could be formed, or you have an issue where potentially somebody can steal credentials and log in because you don't have MFA turned on, things like that, right? So for me, the safest way for you to get those people onto an environment would be through a VPN, right? And we even talk about this inside of the SEC 588 course, where we have a module where we do password credential stuffing on RDP session, because for a Microsoft environment, you can configure your network security group to have a server expose their RDP session to the internet without restriction, and you can have RDP as the main management interface for your Windows environment. Still not ideal to use it, in my opinion, right? It's not as battle hardened as I personally would like. I probably wouldn't put an RDP farm out there and have people connect to it. And even Microsoft, when they do their access gateway, it's a web interface that they have set up for RDP, for remote desktop. And that web interface running on IIS is actually acting as a proxy to get that RDP session set up. So just some things to think about, having exposed RDP. There was actually a ransomware group out there, just so everybody knows, there is a ransomware group out there that they attacked the city of Atlanta, Georgia, and the way that they would get in is RDP. And the reason I know this is because I personally had somebody that was a small business owner come to me, and the person had 5 or 6 small business companies, or maybe a few more. He's a contractor / construction / commercial real estate person. And so if you ever dealt with those people, they have, 8, 9, 10, they have a company per building or whatever. And their QuickBooks was actually just completely encrypted by this ransomware, same ransomware group. And what they were doing was they were scanning the internet for RDP. Just so happens he had a very weak RDP username and password, got in, encrypted the system, and asked for ransom. And so this is something that we're seeing in high regard, right? Not saying that VPNs are necessarily any better or worse from a programmability standpoint, because if you have standard credentials on a VPN, it's the same kind of problem. But VPNs are designed just for security, whereas RDP is designed for, say, manageability. So just some things to think about. As a matter of fact, RDP encryption wasn't even enabled up until 2008 or 2012. So probably not the most ideal thing to do, especially when you have things like Bluekeep and other bugs that were out there. Okay. So we have a few questions, and let's get through them, right? First question, is RDP, and I'm going to just walk through these a few at a time, right? Number one, is RDP over TLS not okay? I would probably not recommend RDP over TLS. I mean, it's encrypted. but you can do some pretty evil stuff with RDP. I don't know if you like RDP can do a lot, and so I really like the protocol. But you could copy and paste documents. You could copy and paste binaries. You can do all sorts of things with RDP. I probably wouldn't have it out on the internet without something wrapping around it for encryption. That's just my question. Brian had another question, which I think, Molly, you answered. Am I right? Yeah, it looks like you answered. Yeah, AWS question. There was a question around the trends of attack around cloud in a cloud environment. I've answered this question in the past, but for anybody that wants to ask this question about our trends in a cloud environment, what I will tell you is that we have had a series of webinars on it, and we will do some cloud trends probably next month. And so you can join us for that, and it'll be recorded and saved. Of course, trends change the trend line. And I think the final question was, that was it. That was the final question. So there we go. If you have any other questions, anybody can put them in the chat room. And I think if that's it, that's all I have for this series, for this edition of the postmodern web attacks, SaltStack, Azure, and RDP. Next month or a month after, depending on how we're doing on certain things, we're going to do another postmodern web attacks. I'm actually going to be doing a few more class runs of Sec 588, and we have a SANS Hackfest Summit happening in a few weeks that is going to be very heavily attended. The speaker list is amazing. So if you haven't signed up for that, here's your chance to see some very, very, very awesome talks that are going to be given. And this is going to be like unheard of. The summit is $0. So just go to the SANS website and sign up for that so you can see the 2 talk tracks. And that's all I got. Molly, you have anything?
Nope.
Well, thanks for jumping in on this. This has kind of been, it's kind of, just like a chill thing for everybody. Hey, it's Memorial Day next weekend. So for all of you out there in the US, I know it's a weird time, but like do something different. Like maybe you want to, I don't know what I'm going to do, but maybe I'm going to do like, instead of like hanging out in this room all day, I'm going to hang out in another room all day. And that'll be my Memorial Day. Huh? All right.
I like it, Moses. That sounds great. All right. Well, thank you so much, Moses and Molly, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.